Holy Quran Anti-Corruption Numerical Patterns. The Quran, considered the holy book of Islam, has fascinated scholars for centuries due to its linguistic richness and intricate numerical patterns. Among these patterns, odd-even number, prime number and the composite number patterns are notable. Odd-even pattern, by the even and the odd. As you see, the third verse of the 89th chapter, the dawn in the Quran draws attention to the even and odd numbers. The word wa in Quran is used to emphasize the words that succeed it when it is used at the beginning of a sentence. Pattern derivation. Add up all the chapter numbers from 1 to 114. The total is 6,555. Add up the number of verses. For each chapter in the Quran the total is 6,236. Now, for each chapter add its chapter number to the number of verses it has. For example, 1 plus 7 equals 8 for the first chapter, 2 plus 286 equals 288 for the next chapter, and we can call the result its s plus a number. If you add up all the odd s plus a numbers the result is 6,555, which as we saw is the sum of the chapter numbers in the Quran. If you add up all the even s plus a numbers, the result is 6,236, which is the sum of all the verses in the Quran. What a coincidence! The same can be seen in this image. The sum of the chapters that contributed to even totals is equal to the sum of verses that contributed to odd totals, which is equal to 3,303. Chapter level protection. This odd-even pattern protects the Holy Quran from not getting corrupted by not allowing any new chapter to be added or existing chapter to be deleted, because 3,303 pattern will collapse. Verse level protection. This odd-even protects the Quran if anyone tries to add, delete odd number of verses to the Quran as 6,555, 6,236 matching will collapse, but it cannot protect if even number of verses are added. Prime numbers introduction. Prime numbers are natural numbers that are divisible by only 1 and the number itself. In other words, prime numbers are positive integers greater than 1 with exactly 2 factors, 1 and the number itself. Some of the prime numbers include 2, 3, 5, 7, 11, 13, etc. Mathematicians have been captivated by the unique nature of primes for centuries, with their seemingly random distribution and infinite abundance. Euclid, the ancient Greek mathematician, proved over 2,000 years ago that there are infinitely many prime numbers. The proof is elegant in its simplicity, and it serves as a timeless reminder of the enduring mysteries that number theory holds. Applications in cryptography. Prime power. In systems like our SL, the security relies on the difficulty of factoring the product of two large prime numbers. The larger the prime numbers, the more challenging the task of factoring becomes, providing a robust foundation for secure communication in the digital age. Reward for the Millennium Prize problem. Riemann hypothesis. First proposed by Bernhard Riemann in 1859, it offers valuable insights into prime numbers, but it is based on an unexplored mathematical landscape. If you can show that its mathematical path will always lie true, $1 million is all yours. The Millennium Prize problems are 7 well-known complex mathematical problems, selected by the Clay Mathematics Institute in 2000. Riemann hypothesis is one among them. The Clay Institute has pledged a $1 million prize for the first correct solution to each problem. Mathematicians are obsessed with primes because they are the foundation of all other numbers. Prime numbers in mathematics are like atoms in chemistry, bricks in the construction industry. Superprimes. Superprime numbers, also known as higher-order primes, or prime index primes, pips, are the subsequence of prime numbers that occupy prime-numbered positions within the sequence of all prime numbers. A superprime is a prime that its index is also a prime. The subsequence begins 3, 5, 11, 17, 31, etc. That is, if p, n, denotes the nth prime number, the numbers in this sequence are those of the form p, n. Prime numbers, pattern. We have found an amazing pattern called dual-layer prime number, DLPNP, from the 32 verse counts of the Holy Quran. Calculation procedure. Listed 30 to prime numbered verses out of 114 chapters. Listed the nth prime number, superprimes, of the prime numbers in third column of the image attached. For example, 7th prime number is 17 and 109th prime number is 599. Calculated the sum of the third column, and got 1076. Calculated the sum of the fourth column, and got 5160. This is nothing but the sum of the verses of rest of the 82 chapters, whose verse counts are composite numbers. Calculated the sum of the values from steps 3 and 4, 1076 plus 5160, equals 6,236, and got 6,236 the total verses of the Holy Quran. DLPNP application. This odd-even pattern protects the Quran if anyone tries to add, delete odd number of verses to the Quran as 6,555 6,236 matching will collapse, but it cannot protect if even number of verses are added or deleted. This is where dual-layer prime number pattern, DLPNP, comes to the rescues and prevents the Holy Quran from getting corrupted. If anyone tries to add, delete even number verses to any one of the 32 chapters, whose verses are prime numbers, DLPNP pattern collapse. If anyone tries to add, delete even number of verses to any one of the rest of the 82 chapters, whose verse counts are composite numbers, 5,160 mismatches with the DLPNP total of 5,160. Composite numbers, introduction. In mathematics, composite numbers are numbers that have more than two factors. These numbers are also called composites. Composite numbers are just the opposite of prime numbers, which have only two factors, i.e., 1 and the number itself. For example, the integer 14 is a composite number, because it is the product of the two smaller integers 2 times 7. Likewise, the integers 2 and 3 are not composite numbers because each of them can only be divided by 1 and itself. Aliquot sum, introduction. In number theory, the Aliquot sum S(n) of a positive integer n is the sum of all proper divisors of n, that is, all divisors of n other than n itself. It can be used to characterize the prime numbers, perfect numbers, sociable numbers, deficient numbers, abundant numbers, and untouchable numbers, and to define the Aliquot sequence of a number. For example, the proper divisors of 12, that is, the positive divisors of 12 that are not equal to 12, are 1, 2, 3, 4, and 6, so the Aliquot sum of 12 is 16. Abundant numbers, introduction. In number theory, an abundant number or excessive number is a positive integer, for which the sum of its proper divisors is greater than the number. The integer 12 is the first abundant number. Its proper divisors are 1, 2, 3, 4, and 6, for a total of 16. The amount by which the sum exceeds the number is the abundance. Definition: a number n for which the sum of divisors sigma n greater than 2n, or, equivalently, the sum of proper divisors, or Aliquot sum, S, n, greater than n. Abundance is the value sigma n minus 2n or S, n, minus n. The first few abundant numbers are 12, 18, 20, 24, 30, 36, 40, etc. Perfect numbers, introduction. In number theory, a perfect number is a positive integer that is equal to the sum of its positive proper divisors, that is, divisors excluding the number itself. For instance, 6 has proper divisors 1, 2, and 3, and 1 plus 2 plus 3 equals 6, so 6 is a perfect number. The next perfect number is 28, since 1 plus 2 plus 4 plus 7 plus 14 equals 28. The sum of proper divisors of a number is called its Aliquot sum, so a perfect number is one that is equal to its Aliquot sum. Composite numbers, pattern. We have found an amazing pattern called Aliquot sum composite number, ASCNP, pattern from the 32 verse counts of the Holy Quran. Calculation procedure. 1. Noted that the Aliquot sums of the 114 verse counts. 2. Taken the sum of all the 114 Aliquot sums, equals 4,480. 3. Number of verse counts where Aliquot sum greater than verse count is 28. 4. Number of verse counts where Aliquot sum equals verse count is 4. 5. Taken the sum of the verse counts of above 28, blue, abundant numbers, and 4, cyan, perfect numbers, entries equals 1,760. 6. The rest of the 50, 114 minus 32 plus 32, chapter verse count is 3,400, 6,236 minus 1,760 plus 1,706, is a multiple of 100. Final observation is, sum of all the 114 Aliquot sums, 4,480, plus sum of the 28 verse counts, 1,760, minus for perfect numbers, 4,480 plus 1,760 minus for equals 6,236, which is nothing but the total number of verses of Holy Quran. God is great. See how the pattern prevent the corruption. If anyone try to add or delete the new or existing verses, the Aliquot sum changes to different value, and if anyone changes verses from these 32 chapters, the verse total changes from 1,760. Here for perfect numbers helped in completing the pattern. DLPN pattern versus ASCN pattern. The symmetry is 1. There are 32 prime numbers in DLPN pattern, and 32 composite numbers in ASCN pattern. 2. There are 1,076 total verses in DLPN pattern, and 1,760 total verses in ASCN pattern. Both have same digits 0, 1, 6 and 7. Thank you for your time.